Welcome everybody to today's session in Group ABAP in DevOps. My name is Harald Kehr. I am from SAP Germany. I am responsible for assembly and validation of ABAP software. So what is the agenda for today? What is GCTS? This is the first one. Then second, how ABAP works with Git. So this is new. This ABAP now enabled. We enable it with Git. And last but not least, CI, so continuous integration for ABAP. So what is the status as today? We have here the SAP S/4HANA. This is the main product of SAP. It provides many solutions for various business requirements and is mainly based on ABAP as a programming language. The ABAP itself, it provides an integration by nature, so it is designed to have integration. It works mainly on database tables, so normally stores everything in database tables, and is known for fast and easy data processing. And last but not least, the CTS, the change and transport system. Typical system landscape is a development system, S4D, a quality system, S4Q, and a productive system, S4P. Today, development will store and transport requests, and these transport requests are propagated through the landscapes, from the development to Q to the productive system. This is as it is today. So what comes new now? Now we introduce Git with ABAP. Git is an open source distributed control system, so it's a repository many other programming languages use for storing their code. It separates development in branches, so you can have separate branches for different releases or features or maintenance. It stores readable files in the repository, so you can access it, read it with an editor, and the source code can be easily shared with other developers, people, open source, and so on. Also, this is, I think, one of the big benefits of Git, CI, so continuous integration processes can be easily set up. And these CI processes are integrated in the most programming or modern programming languages like Java, Python, and so on. What about ABAP? Up to today, ABAP is not integrated. So that's what we have done now. We integrated also ABAP with Git. How does this work? So what we have done, we combined the best worlds. So the classical change and transport system, we combined with Git, and this becomes GCTS, the JIT-enabled CTS. What use cases have we? One is distributed development. This will enable us to have a decentralized development environment. One project can have his one system, own development system, don't interfere with other ones. Also, big benefit, we can enable continuous integration. So changes can be deployed automatically and also tested automatically. And the developer gets immediately feedback if it was fine or the test did fail. And just stable stages can be deployed. If there's an error, we can revert to the last stable change. Also, Git enables us branch-based development. So we can support various releases within the Git. We can also use it for feature development within one release and also for maintenance. So how does this new world look like? So developers, as usual, he can work with ABAP development tools, ATT, or classically, as he wants, with SE80 or SE09. This does not change. If the customer changes coding, creates coding, this is stored in a transport from the CTS, and the changes are tracked in this transport. When he is done with his development, he releases his transport, and this is now new. What happens now? The transport is not exported, but the change is pushed to the Git. What then happens? We can have a CI server, like Jenkins, which observes, and if there's a change, this can automatically deploy this to a queue system, this change, and also run automated tests, and give feedback to the developer. Was everything fine? Did it fail? If everything is fine, this can then be automatically merged in the main branch, the release branch, and automatically pulled to follow-on system, like productive system. And then this is imported into the runtime of the follow-on systems with the transport and becomes active in the follow-on systems. The basic flow of such a continuous integration looks like this. Developer writes the coding, the developer pushes the change to a repository, the changes are available for third parties or other colleagues. They can also now work on this. A CI server observes if there's a change. If so, he creates automatically a new build, deploys this build to the runtime system, and runs automated tests. And at the end, the developer gets feedback. Did it fail? Was it successfully? So this is a circle of continuous integration. We have now enabled also for ABAP. What use case are we thinking about? The first use case is what I already shown you, is this continuous integration. So we can fully automate the development. So developer commits a change. This is automatically transferred to a Git server. This is observed by a CI server. This then launches some tests, deploys it, and launches some tests. If the test is successfully, it automatically deploys it to the production system, and you are done. This is the straightforward part. If the test fails, what happens? The Git can revert to the last successful commit, so you can, the faulty one, revert it to the last one and send it back to the developer. So you always have on the quality systems the last successful state of the software, not faulty ones. Next use case is doing a feature development and the maintenance in parallel. What you typically have, if you have a productive system, here this is MTD as a development system, MTQ as a quality, and then the MTP as a productive landscape where you run your business. And up to now, what do you do if you want to do a feature development? Then you have to set up new systems like NFD, NFQ, do the feature development there. After this is successfully, then comes the hard work, how to bring the features into the other system landscape. This can be hard with adjustments. How does it work with Git? This is much more easier. What do you in Git? You have this master branch where your current development is stored. And if you want to do a feature development, you clone this master branch to a feature branch. In the feature branch, you do your development, and if everything is fine, you merge this together in the master. In this scenario, the productive system stays on a different branch, on the production branch. In the same landscape, this is not touched even if you have errors, because only the quality system and the development system are linked to the feature branch. And if you are done and have merged it back to the master after successfully, then you can deploy it to the production system within one landscape. So you can dynamically switch between branches and don't need additional systems. Next use case is distributed development. Here, the idea is two dev teams can work on the same object without locking each other. After a team is done, or a developer is done, he commits his change into the central repository. The second one can also commit. If the changes are on different parts of the object, the merge can be done automatically. If not, maybe some manual merging is done, so this is not fully automated. But then also our pipeline can start. This merged coding is then put into a quality system, run automated tests, and if everything is successfully, deploy this to production. I think this is a scenario for bigger development projects where you have often the issues if you have many developers that they lock each other. What are timelines and features? So recent innovation, what we have delivered with the current release, so the S/4HANA 1909, is this Git-based distribution of custom development. So of own development, you can use it, distribute it. This is fully implemented. Also, the full support of continuous integration. So you can trigger pipelines, you can trigger automated tests, and also trigger the deployment, automatic deployment. What are planned innovations for the future? What I showed you, the feature development and the maintenance in parallel, we would want to enhance this. Also, this scenario use case of distributed development we will enhance. What is missing up to now is customizing support. So table entries is hard to covered with Git, so this needs some enhancements. So in future you can also transport your customizing with Git. Also Docker support and the versioning of all object types in Git. All ABAP object types should be can be versioned within Git. And the main innovation or what we will do is we will to provide a user interface for this merging. So if you have to merge tables, definitions, it's a little bit hard at the moment. And this is the main tool in future for the merging of different feature branches or distributed development together. For what do we CI? So this is now the new world. ABAP also will join. So for agile development with Git, do the integration into CI with common tools known for all other programming languages. Also do this branching concept, so we don't need a new system landscape for every new release. You can do it within separate branches, and also the automatic deployment. Now the ABAP has joined the world of all other modern programming languages. If you have questions, I'm available after this talk. So questions, I stay outside, you can ask me outside. And last but not least, here's the contact for further topics. This is Karin Spiegel. So if you have additional questions for this, then please send Karin a mail and we will give you the additional information about this. So that's it. Thank you very much.